What if I told you that Schrödinger's cat, the most famous feline in physics, might not need to be frozen to be both dead and alive? For the first time ever, scientists have observed a quantum Schrödinger's cat state that survives at high temperatures, and it's completely changing what we thought we knew about the quantum world. For nearly a century, the rules of the game were simple. To see the bizarre effects of quantum mechanics, you had to go cold. I'm talking about temperatures colder than deep space, just a fraction of a degree above absolute zero. Why? Because of a pesky little thing called decoherence. Think of a quantum state like a delicate soap bubble. The slightest disturbance or bit of heat, a stray vibration and poof, the bubble pops, the quantum weirdness vanishes, and it collapses into a single, boring classical state. This is why building practical quantum computers has been so incredibly hard. We've been fighting a constant battle against the warmth of the everyday world. But now, a groundbreaking experiment has thrown that old rulebook out the window. A team of brilliant researchers has managed to create and sustain a macroscopic quantum superposition and Schrödinger's cat at temperatures far warmer than the usual cryogenic chill. This isn't just a small step, it's a giant leap that could fundamentally reshape the future of technology. So, what exactly is a Schrödinger's cat state in this context? Let's do a quick recap of the famous thought experiment. Erwin Schrödinger imagined a cat in a sealed box with a radioactive atom. If the atom decays, a mechanism releases poison, and the cat dies. If it doesn't decay, the cat lives. According to quantum mechanics, until you open the box and look, the atom is in a superposition of both decayed and not decayed. This means the cat is bizarrely both alive and dead at the same time. Of course, we don't do this with real cats. In the lab, a cat state refers to a large object, or a collection of many particles, being in two distinct states at once. For example, imagine a tiny vibrating drumhead that is simultaneously vibrating and not vibrating. That's a cat state. Until now, creating such a state with a large object and keeping it from collapsing required extreme cold to minimize environmental noise. So how did these scientists pull off this seemingly impossible feat? The secret lies in a combination of advanced materials and incredible precision. They didn't just try to shield their quantum system from the heat. They engineered a system that is inherently robust against it, by using specific types of quantum particles and manipulating their interactions with extreme accuracy. They created a quantum state that could effectively ignore the thermal noise that would normally destroy it instantly. It's like building a submarine that can withstand the crushing pressures of the deep ocean. But for the quantum realm, with heat being the pressure, this breakthrough is about more than just a cool lab result. It tackles one of the biggest hurdles in quantum technology, decoherence. The need for cryogenic cooling is a massive bottleneck for building practical quantum devices. Imagine trying to use a laptop that had to be kept in a super freezer the size of a room. It's just not practical. By demonstrating that quantum coherence can persist in warmer, more real-world conditions, this research opens the door to a new generation of quantum technologies. Think about the implications. Quantum computers could become more compact, cheaper, and more accessible. We could have quantum sensors, so sensitive they could detect the faintest gravitational waves or even see inside the human brain with unprecedented detail, all without needing a giant, expensive cooling apparatus. Quantum communication networks, which promise unhackable communication, could become far easier to build and deploy across the globe. This isn't just an incremental improvement, it's a potential paradigm shift. It makes the dream of a quantum-powered future feel much closer to reality. Beyond the technological implications, this discovery touches upon the very foundations of physics. The Schrödinger's cat paradox was originally conceived to highlight the absurdity of applying quantum rules to the macroscopic world we live in. There's a fuzzy boundary between the quantum realm, where things can be in two places at once, and our classical world, where a cat is either alive or dead, not both. This experiment blurs that line even further. It shows us that the quantumness of reality doesn't just disappear when things get bigger and warmer. It's still there, just hiding. This forces us to reconsider our fundamental understanding of how the quantum world transitions into the classical world we experience every day. It's a profound philosophical question that physicists have debated for decades. And this experiment provides a crucial new piece of the puzzle. So, what's next on the horizon? The immediate goal is to build on this success. Scientists will work to extend the lifetime of these hot quantum states and to scale them up, incorporating more and more particles into the superposition. The ultimate dream is to achieve a stable, room-temperature quantum system that can be used to build powerful, practical devices. We're still a long way from having a quantum computer on our desks, but this research proves that it might not be as far off as we once thought. The path to room-temperature quantum computing is no longer just a theoretical dream. It's now an active and promising field of research. This discovery is a testament to human ingenuity in our relentless quest to understand the universe. We've taken one of the most counterintuitive ideas in all of science and are slowly but surely learning to tame it. The quantum cat is out of the cryogenic box, and it's looking very much alive. The future is quantum, and it's heating up. Thank you so much for joining me on this incredible journey into the quantum world. If you found this as fascinating as I did, make sure to hit that like button and subscribe to the channel for more deep dives into the science that's shaping our future. Let me know your thoughts in the comments below. What quantum technology are you most excited about? Thanks for watching, and I'll see you in the next video.